Mathematics, Advanced Subsidiary Level, Paper 1, 2022, Part 4. Question number 8. A flexible piece of wire, 60 centimeter long, is bent to form the perimeter of a sector of a circle AOB. So it's bent in this form. Can I just show you? In this form. Okay. The radius of the circle r centimeter and the angle is theta. So radius and theta. Express theta in terms of r and show that the area of the sector is given by this. Okay, so let's just start. And again, we are going to go to our formula sheet to see if we can find the formula of a sector. Okay, so let's just go, or the perimeter for a sector. So let's just go. And I show you, it's on the formula sheet. So please use it and always start using it already in the classroom so that you are familiar with the formula sheet. Okay, so here. So the arc length, let's just going to see which is, yes, that one. So its arc length of a circle is, so it will only be the curved part is going to be r theta. Okay, let's just go back. Okay. Still not enough. Okay, here it is. So basically, the formula that I showed you will just be this part. But remember, the wire was for the whole perimeter. So I can say the perimeter of the sector is going to be that r theta plus, but also that r as well as that r. So also plus 2r. Okay. Now, I'm telling you that it's 60. So in the place of this, I can put 60. Now I want to show you. Now, I must decide who am I going to make? Because remember, they go to area. We will know, I should have actually showed you the area also. But we must see in terms of what? Now, if we do it in terms of r, let's rather do it in terms of theta, because there's only one theta. And also, you can take the root of r. And if it's not working, then you can continue with the root of making theta the subject. Okay, but I'm going to go for theta. And I'm just rather going to say minus 2r. So I will get that theta, if I divide r on both sides, I'm going to get, let's just put here, I just want to take one lower step. Okay, so I'm going to get that it's 60 minus 2r over r. Just keep it like that. Now, as I said, because they say express the area, that was for the perimeter. Didn't show you the area. So let's go again. No problem. Okay, so there was the area. So the area of a sector was a half r squared theta. So if you didn't memorize it, just go to your formula sheet. So let's just go back again. Okay. Okay. So basically, I'm just going to say, okay, now the area of the sector, let's just get my pen correct. Area of the sector is going to be a half r squared theta. So that is going to be, now I'm going to say a half, leave r squared. Can you see why I didn't make r? Because then you had to come with square. But as I said, if it's not working, scratch and then go to the other option. But now I can just say 60 minus 2r over r. Okay. Now I can simplify this by going now to this one. So if I'm going to say, okay, I can multiply this basically in. So put this over 1. Do you see there? Then I'm actually just want to show you. So it's half r squared then it's 60 minus 2r, and then over r. I'm just putting that step in, that makes. So if I multiply it in, I'm going to, half of 60 will be 30, and you see that's the 30 I'm looking for. Then it's going to be r squared minus 2r to the power of 3 over r. And what I'm going to do now, I'm going to take r out as a common factor on top. So it's 30r minus 2r squared, because then I must create one term over one term. There it was two terms over one term, but now it's one term over one term, and the r's can cancel out. So now I'm left with 30r minus 2r squared. And you can end by the statement a equals 30r minus 2r squared. Okay, but remember this was question number A. I'm just going to take you quickly first to the exam report. And then, because if the question was long, then I realized that it's sometimes better that you go to the exam report first. Okay, so let's just quickly see. Just number A, poorly done. A common wrong approach was the learners. This is incorrect. It's 60. So they forgot about the plus 2r. Okay, so this was correct. And then some, and then you got this. Okay, and then I'm going back to number B. So let's go back to the question paper and let's go to question number B. Okay, so then I'm going to start. Given that r can vary, find the stationary values. Now, as soon as I see stationary values, there's almost like keywords that's just taking your mind to a topic. So stationary values, then I think differentiation. Okay, so find the stationary value of A and determine its nature. Okay, so I'm going to, this is why they gave you the formula. So don't use, if you didn't come to that formula, use the correct one that they gave you. Okay, that was the formula. So differentiate it, dA over dr, and that's going to be 30 minus 2r. So at the stationary points, and I didn't give you a page here, I just want to see if I gave you on the previous one a page, because I had the page there. On the previous one, you could have checked on page 146. There you would have found the formula. Example 6 would have helped you. Let's go back to this one in the textbook. You can now go and check on page 284, and page 285. That will help you. Okay. And then I'll come now to the nature of the point. So at the stationary point, dA over dr will be equal to 0. So basically, this differentiated derivative will be equal to 0. So 30 equals 2r. So therefore, the value of r will be equal to 15. Okay. Now, when r is 15, so when r is 15, then a will be equal to 30. So substitute it in the original equation. 15 minus 15 squared. And that will be 450 minus 225. And that will be exactly 225. That's the half. So therefore, find the stationary. A is equal to 225. Okay, unit square. Now, let's just go on. You can say A because given that the stationary point, yes, I think you can say here. No, not that it's necessary, no unit square. Now, if you come to the nature of the points, then you can go to page 288 and you can look at example 28 in my textbook. So basically, I think for me, always to double differentiate is the easiest one, but you can also try the other method. So I'm going to go for the double differentiation. And that is actually, remember, I'm taking this and I differentiate again. So what do I get? I'm just getting Negative 2. So it's a negative value. So if it's a negative value, therefore it's a maximum point. And I just want to show you, say somebody would have the other method, let's just see, you don't have to do both, please. Other method, and you will see it on page 285. And then because now, as I said, the value was that 15. Let me just see, where did I got that 15? Okay, so it was the value of R there. So if you take 15, then you must take a value in front, say 14 and 16, to determine how the curve will go. Okay, so if you go and you substitute F14, the point before, and you go 30 minus 2, 14, okay, in the original, then you're going to get 2. Okay, so it's meaning it's first positive. And if you substitute the point after, then it's 30 minus 2, 16, and that would have been 30 minus 32, and that would be negative 2. And then it's coming negative. And that will also, therefore, a maximum point. Doesn't matter what method. So please don't do both, any of the methods. It's just because this one didn't give you a variable that I was just showing you, you could have tested. Okay, and then we just go to the exam report, and we're just going to see what they tell us there. Question number B, I'll just go on. So there, and you get that, it's the 2 to 5. I use any method, and as long as you come to a maximum point. So well answered, except that A was omitted. Okay, so people didn't substitute in the original. Remember, they asked the value of A. Okay, so you must find R to find the value of A. Question number 9. Show that the equation, and then you can see it's a trigonometric equation, can be written in the form. Okay, and then they give you the form. So you will start with this one, not with the last one, with the first one. So start by saying 3 tan x equals negative 2 cos x. And you can look on page in the textbook 197 to 200. There you will find the identities. But the best way is always to get everything in terms of sin and cos. And I just want to go to the formula sheet. Let's just go to the formula sheet. Oh, tan is so easy. I think you know tan is sin x over cos x. But I just want on the formula sheet to see if you can see it also here. Okay, it's not this page. Oh, there's trigonometry. Let's just check there. I think it's here. You will see it here. Yes, tan theta equals sin theta over cos theta. Now remember, you're not going to use theta because you use what is written in the example. And in the example, it's x. So you're going to say tan x, the identity is equal to sin x over cos x. Okay, so let's just go back. Okay, almost there. So we start by that. So we keep the 3 on top. So sin x over cos x. And negative 2 cos x over 1. Okay, then cross multiply. And if I cross, I get negative 2 cos square x is equal to 3 sin x. And unfortunately, I have to go again. I'm looking for this identity to see if it's also cos square x plus sin square x is equal to 1. Okay, I should have already checked it, but I really just want to show you, and I really want you to focus on the formula sheet if you are struggling. Okay, so it's not this page. Let's just see. There it is. There it is. Nice. Do you see it? There. Cos square theta plus sin square theta is equal to 1. But now we're just going to use x. Okay, so let's just go back. Okay. So basically, I'm going to just make cos square x the subject of the formula. So if it's, then it's cos square x is equal to 1 minus sin square x. So then it's going to be negative 2. So 1 minus sin square x, and that's equal to 3 sin x. So it's negative 2 plus 2, it becomes a positive, okay? And take the 3 over sin x and put it equal to 0. So it's going to be 2 sin square x minus 3 sin x minus 2 is equal to 0. So you can actually say therefore. And that's exactly what's standing there. Okay. So that was not difficult. So hence solve the equation. Now they give you the original, but it's again this word hence. So they wanted you to use that one that you derived. Okay, but very, very important. It's in radians. Okay, so your calculator must be on radians if you're going to work with the calculators. And if it's 0 to 2, so it's actually saying 0 to 360. Okay, so let's just start. So if I start there, I'm going to say 2 sin square x minus 3 sin x minus 2, and that will be equal to 0. Okay, factorization. Let's go for that. So let's make 2 and 2, 2 and 2, 2 and 1, 2 and 1, and 1 and 2, because that's 4 minus 1, and that will be 3. And the biggest overcross will be get negative, and this is positive. And then this is sin x. So I'm going to get sin x, let's just get my pen, sin x minus 2 and 2 sin x plus 1. And that's equal to 0. So I have sin x is equal to 2, or 2 sin x is equal to negative 1. So sin x is 2, or sin x is negative a half. Now, you can even test it on the calculator, but the sin graph, and I just want, the sin graph is going like this, because it's just x. So it's going just from 1 to negative 1. This will not be applicable. But you can even test it by checking it on the calculator. But you will get, say for example, this mine I think is now on degrees, but say shift sin 2 equals, it's going to give you a maths error. So you can just say they're not applicable. And you continue with this one. Now, if you go to page 201, because it's a half, it's actually 30 degrees. And on page 211, example 50 will help you. Okay, but if you want to see that table, that I do it without a calculator, you will go to page 168. And that table I'm referring to is this one. Okay, so it was an equilateral triangle, actually. So it's the half of an equilateral. And then I like to first write the degrees, and it's like, okay, now take it from there. This was originally 60, and this was cut into the half. So this was 30. Okay. This was originally 2, cut into half 1. Pythagoras theorem, square root 3. But the 30, remember also always, is pi over 6. And the 60 is not having, it's pi over 3. Are you with me? So I want to show you how I'm going to do it without a calculator. And then I will show you how to do it also with a calculator. Okay, but let's just do it without. So when I see it's sin, if I'm going to go to my cast diagram, where is sin negative? It's positive in quadrant 1 and 2, and it's negative in quadrant 3 and 4. Okay. So it's there and there. Now, that's all that the negative is telling me. The rest, if it's 1 over 2 and it's sin, do you see? Sin, it's opposite over hypotenuse, then it's pi over 6. So that basic angle, I rather want to keep first to blue, that basic angle angle will be pi over 6. So that angle there is pi over 6. That angle there is pi over 6. But I'm looking from there to there. So what I'm actually looking for to find x, it's the pi, because that's pi, half, 360, okay, or 180, plus pi over 6. So that will be 7 pi over 6, or I'm looking for from there to there. Oh, it's a little bit too much. From there to there. So it will be 2 pi minus pi over 6. And that will be, 2 pi will be 12 pi over 6. But then 12 minus 1, so it will be 11. Okay, let's just go back. It will be 11 pi over 6. Okay, that's the two values without a calculator. If you want to the calculator, then you must first put the calculator on radians. Now, what I press on my calculator, I press mode, and then 2, but I don't know yours. Okay, now, I must then first find the reference angle. So I will say, not the negative, I will say shift, and then sin bracket 1 divide 2, close the bracket, equals. And remember that the reference angle, you must make it at least, I would say, if you make it to 4 decimal places or 4 significant figures, it will work. But so make it 0. Okay, so let's rather go for 5. I'll show you now. So it's 5 to, yes, make it, 0.5236. Okay, so then to get x, it can be 1 pi plus that 0.5236. And it's always good to first write your calculator display down, okay? But then it will give you 3. Okay, so pi, let's just go, if I go shift pi, I just want to find my pi, plus 0.5236, I get on my calculator 3,6651927. Okay, you fool. According to me, if I look at the front page, I don't see it in the exam report, but if you look at the front page, I want to go you back. I think they have 3 decimal places, but in the exam report. But if I look here, I see that angles in radians to 3 significant figures. So I think it's maybe just a typing error in the exam report, but it can always be better, and I think it's just a better answer. Okay, so let's just go back there. So basically, if it's to 3 significant figures, then it would be 3.66. And then the other one, or, then it would be 2 pi, so 2 pi minus, 0.5236. So 2 multiply pi minus 0.5236. And that would be equal to 5. First the calculator display 759585307, but 3 significant figures, and my will be 5. Let's just see, 5.76. Okay, so that. But can you see to work? Oh, this is excellent. Then you will get full marks. Okay, but let's just go to the exam report, and I just show it to you. So if I go to the exam report, just want to see, this is question number 9. I just want to see if it's on this page. No, it's on the next page. So let's just see what they say here. Again, the given identities on the sheet were not correctly copied, okay, converted correctly. Learners should state clearly the quoted answer. Okay, so basically, yes, you just say, therefore, you must end with this answer. Not begin, end. Then learners did get sin 2, but did not apply the cast rule correctly or gave a negative angle as an answer. Others gave more than two answers. But there, can you see why I say maybe it's maybe the better answer, because according to me, radians is to three significant figures. I think it was in the beginning to three decimal places in the higher level, and now it's to three significant figures, what I see in front of the page. Okay, but there, can you see, this is beautiful. 7 pi over 6, 11 pi over 6. That would be brilliant if you do that. As your final exams approach, I want to highlight the importance of the y equals mx+c mathematics textbooks. If you don't have them yet, you can find them at the following bookshops. These textbooks will be your reliable study companions, guiding you towards mathematical success. For educators aiming for exceptional maths exam results, start using the y equals mx+c mathematics textbooks used by leading schools in your classroom. They are part of the NEET catalogue and can be easily obtained within your ministry's textbook budget. Make sure to communicate your request to your region's procurement department to empower your learners with the best educational resources. Furthermore, schools have the option to place direct orders with us, and we offer bulk order discounts. Reach out to us via email at the address below. Best of luck in your maths journey.